Hello friends, welcome to the session. In this session we'll be discussing about Kirchhoffs voltage law. Kirchhoffs laws are used whenever we want to analyze any given electrical circuit and whenever we want to determine the voltage or current at any point in the electrical circuit, then it is necessary to make the use of Kirchhoffs laws. The first Kirchhoffs law is called as the Kirchhoffs current law, which we have already discussed, and now we will discuss the Kirchhoffs voltage law. So let us see what this law states and how it can be used to write the equation for any given electrical circuit. So we'll be making the use of the iPad for recording of the session. So now let us understand what the Kirchhoffs voltage law states to us. Kirchhoffs voltage law, or in short we call it as a KVL. So Kirchhoffs voltage law states that the sum of all EMFs or voltages and the IR drop or voltage drop across the resistance in any closed electric circuit is equal to 0. That is, whenever we make the summation of all EMFs that are present in the circuit, and when we add the voltage drop across the resistance called as the IR drop, current and resistance drop, then the summation of all this in any electric circuit is equal to 0. That is, the summation of EMFs plus the summation of IR drop in any electric circuit is equal to 0. So this is the statement of the Kirchhoffs voltage law. Now, in order to make the use of the Kirchhoffs voltage law, we need to decide the sign conventions. So the first thing that we need to do whenever we have been given any closed electric circuit, the direction of tracing. We need to trace the circuit. So direction of tracing of the circuit can be either clockwise or it can be anti-clockwise. So you need to decide what should be the circuit. It can be a clockwise or it can be anti-clockwise. Now the EMF is taken as positive. So we will take the EMF as positive if it is increasing in the direction of tracing. That is, whenever we are going from negative terminal to positive terminal of the EMF, then that EMF is treated as positive. And the IR drop is also treated as positive if it is increasing. So if the voltage drop across the resistance is also increasing in the direction of tracing, then it is treated as positive. And the EMF, if it is increasing, then it is also treated as positive. So one has to remember these three things, isn't it? First of all, you need to decide the direction of tracing. Either you can go clockwise or anti-clockwise for the tracing of the circuit. Take the EMF or voltage as positive if it is increasing, that is whenever you are going from negative terminal to positive terminal. But if you are going from positive terminal to negative terminal, then it is to be treated as negative. Similarly, the voltage drop across the resistance is to be treated as positive if it is increasing. So if it is in the direction of the current, then it is negative. If it is in the opposite direction of the current, then it is to be treated as a positive. Now we will see one simple circuit and we will see how we can write the KVL equation. Suppose we have been given a closed circuit which consists of these four resistances and which consist of two batteries, say EMF E1, EMF E2. This is the resistance R1, R2, R3 and R4. Suppose the current flowing through this resistance is I1, current flowing through this resistance is I2, current flowing through this resistance is I3 and current flowing through this resistance is I4. Now suppose our direction of tracing of the circuit is clockwise. So remember, we have taken the direction of tracing as clockwise. Now from the above rules we can easily write I1 R1 is to be rated as negative because our direction of tracing is clockwise and the voltage drop I1 R1 is decreasing and therefore it is treated as negative. The voltage drop I2 R2 is to be treated as positive because it is increasing in the direction of tracing. The EMF E2 is treated as negative because we are going from positive terminal to negative terminal. The voltage drop I3 R3 is treated as negative because it is decreasing in the direction of tracing. The EMF E1 is to be treated as positive because we are going from negative terminal to positive terminal and therefore it is increasing. And the voltage drop I4 into R4, it is also negative because the voltage drop is decreasing. And therefore we can write the KVL equation for this circuit, closed circuit, as minus I1 R1 plus I2 R2 minus E2 minus I3 R3 plus E1 minus I4 R4 is equal to 0. Or we can write the same equation as minus I1 R1 plus I2 R2 minus I3 R3 minus I4 R4 is equal to E2 minus E1. So this is the equation which is called as the Kirchhoffs equation, and this is the equation that can be obtained for this circuit. And by using this equation we can easily find the values of currents and voltages at the different point in the given electrical circuit.